Hey guys, how's it going? Mike coming back at you with another video on discrete mathematics. In the previous video, we saw a couple sample problems, some more real-life samples, seeing how we find the union and intersection and difference and the complement of two sets. In this video and the next video, we're going to talk about properties of sets, just some sort of basic laws, identities almost of sets, and how to prove relationships between two sets. We're going to see how we show that a subset is, or we're going to show how one set is a subset of some other set, and then we're also going to show how two sets are equal to each other. So first up, just a couple basic properties for all sets A, B, and C. All that property number one is really saying is that the intersection of two sets is a subset of each set. So A intersect B is a subset of A, and A intersect B is a subset of B. The second one, inclusion in union, all that's really saying is that if you have two sets A and B, then A and likewise B is going to be a subset of the union of those two sets. So A is a subset of A union B, and B is a subset of A union B. In three, a very common property that we've seen showing up in this course, as well as other math courses, transitivity. If A is a subset of B and B is a subset of C, then we know that A has to be a subset of C. So these are the two really main steps that you use and you show to show that if you have two given sets, X and Y, this is how you show that X is a subset of Y. So suppose that little x is a particular yet arbitrarily chosen element of capital X. So we're going to let some guy be in the set capital X. We want to show that this guy little x is in capital Y. And how do we actually do that? When we saw how to prove mathematical statements and mathematical facts, we had a set of sort of definitions or some basic facts that we worked with. So that's what we're going to do here. We're going to introduce some basic facts and some basic definitions that we'll use to help us prove that something is a subset of some other set. So we have two given sets, capital X and capital Y. These are subsets of some universal set, capital U. And then if we have two elements, little x and little y, in this universal set U. Number one, to say that little x is in capital X union capital Y, by definition, little x is in capital X or little x is in capital Y. Notice the thick double arrow, that is if and only if. So that is essentially saying these things are the same thing. Saying x is in the union is saying x is in one set or it's in the other set in the union. Property number two, to say that little x is in capital X intersect capital Y, means that x is in capital X and x is in capital and little x is in capital Y. Three, to say that little x is in capital X minus capital Y, by definition, then little x is in capital X and little x is not in capital Y. Again, the difference set x minus y is all the stuff in x that is also not in y at the same time. Four, little x is an element of capital X complement. By definition just means little x is not in capital X. These are the four most common ones that you're going to have to use. I included a fifth one here. This one involves the Cartesian product. Not really going to have to use it in this course, but just something to see. The ordered pair little x comma little y is an element of capital X times or cross capital Y. By definition, that means little x is in capital X and little y is in capital Y. So let's do a really basic proof here. We're going to prove one of our properties from earlier on in this video. We're going to prove that the intersection of A and B is a subset of A. So I'm going to pick some particular yet arbitrarily chosen guy little x in this set. So this right here is like my step 1. Not step 7. This is my step 1 really here. I'm saying let x be in the set, or suppose x is in this set. Now we are going to use other basic definitions like the ones we just saw, numbers 1 through 4 at the top of your screen, and we want to show that x is in A. Well, we've supposed that x is in the intersection, is in A intersect B, so then by definition, using number 2 here, x is in A and x is in B. Well, we wanted to show that x was in A. We then saw, by definition of x being in the intersection, that x lies in that set A as well. So I just rewrote, therefore, x is in A, and A intersect B is a subset of A. This is a very low-level, very basic type of proof here. A very basic proof that one set is a subset of some other set. In the practice problems that you'll get, you'll see some examples that are a little bit more involved. So this is all I wanted to introduce in this video. In the next video, we'll continue on with these properties of sets. If you have any questions or comments, be sure to drop them in the comment section below. Otherwise, until the next video, take it easy, guys.